Tonight, somewhere on Earth, 4 astronauts are training, quietly, methodically, repeating the same motions, the same procedures again and again. They've been preparing for years for a journey that will last only days, a journey that will carry them away from everything familiar, away from the warmth of Earth, and into the deep, silent darkness beyond. In 2025, they'll board Orion and travel farther from home than any human has in over 50 years. They'll circle the moon, and from there they'll see Earth as it truly is, small, bright, and alone. Take a slow breath. Let the noise of the day fade. Tonight isn't about rockets or timelines. It's about something quieter. Tonight, we're not asking how we go to space. We're asking why we feel the need to go at all. But here's the question. Why are we sending them? Why, after half a century of staying close to Earth, are we returning to deep space? Why do we spend billions, risk lives, devote careers to leaving the only world we've ever known? The easy answers feel insufficient. We go for science, for technology, for progress. But these are justifications, not reasons. They're what appears in mission proposals and budget requests. They're true, but they're not the truth. Not the whole truth. The real reasons are deeper, more primal, harder to articulate in PowerPoint presentations and congressional hearings. They touch something fundamental about what it means to be human, about consciousness arising on this world and refusing to stay confined here, about intelligence that can contemplate the cosmos and feels compelled to reach toward it. I'm the sleepless astronaut, and tonight we're exploring not the how of space exploration, but the why. Not the rockets and orbits and engineering challenges, but the motivations that drive us to build those rockets in the first place. The reasons we look at the moon, at Mars, at distant stars, and feel pulled toward them, despite the danger, despite the cost, despite every rational argument for staying home. Some of these reasons are practical: survival, resources, technological advancement. Others are philosophical: curiosity, perspective, the search for meaning. And some resist easy categorization. They're almost spiritual, though you don't need religion to feel them. The sense that we're meant to go, that staying confined to Earth is wrong somehow, that our future lies out there, even if saying so sounds grandiose. These reasons overlap, reinforce each other, create a web of motivation stronger than any single justification. We don't go to space for one reason. We go for many, each valid, each contributing to the overwhelming sense that this is what intelligence does when it emerges on a world. It looks up, wonders, and eventually reaches. Human beings have always explored. We crossed oceans not knowing what lay beyond the horizon. We climbed mountains that offered no practical benefit. We mapped continents, traversed deserts, reached poles. This isn't recent behavior. Our ancestors spread from Africa across the entire world, venturing into unknown territories, adapting to impossible climates, persisting despite overwhelming odds. What drives this? Not just curiosity, though that's part of it. Not just competition, though that motivates too. Something deeper. A restlessness, a refusal to stay put, a compulsion to see what's over the next hill, across the next ocean, beyond the next frontier. We're a species that moves, explores, pushes boundaries. It's woven into what we are. Space is the frontier we face now. Not the final one. There's no final frontier, only ever-receding horizons. But it's the one challenging us currently, testing us with its scale and hostility and sheer difficulty. And we're responding the way humans always respond to frontiers, by crossing them, by refusing to accept boundaries, by reaching beyond what seems possible. But space is different from previous frontiers. The distances are incomprehensible. The environment is absolutely lethal. The costs are enormous. Going to the moon isn't like sailing to a new continent. It's orders of magnitude harder, more expensive, more dangerous. So why do it? Why invest so much for so little immediate return? Because the reasons for going to space aren't separate from the reasons for solving Earth's problems. They're connected. Space exploration changes how we see ourselves, develops technologies that address terrestrial challenges, unites us around common goals, provides perspective that makes planetary problems seem both urgent and solvable. And because ultimately staying isn't an option. Not if we want our species to persist beyond this century, this millennium, this epoch. Earth is home, but it's not prison. We're not meant to remain here forever any more than our ancestors were meant to remain in Africa forever. We spread. It's what we do. The Artemis 2 crew training right now understands this intuitively. They're not going to the moon because someone handed them a checklist and said, accomplish these objectives. They're going because humans go to frontiers. Because when you can see something and imagine reaching it, you eventually try. Because the moon is there, and we're here, and the distance between creates tension that can only be resolved by crossing it. So tonight, let's explore why. Not just why Artemis 2, but why any of it. Why we built Apollo 50 years ago. Why we're building Artemis now. Why we'll build whatever comes next, pushing farther, going deeper, refusing to be contained. 7 reasons. Some practical, some philosophical, all intertwined. Together they explain not just why we go to space, but why we must, why we will, why we'll never stop until we've spread across the solar system and beyond, carrying consciousness and curiosity with us wherever we go. Let's begin with the most urgent reason, the one that justifies everything else even if every other reason disappeared: survival. Every human who has ever lived, 8 billion people currently, over 100 billion throughout history, has lived on the same planet. Every achievement, every civilization, every work of art and scientific discovery and moment of joy or suffering, all of it happened here. Earth is the only world we've ever known, the only home our species has ever had. And it's not enough. Not because Earth is inadequate. This planet is extraordinary, uniquely suited to life, the only world we've found where complex organisms thrive. But Earth is also vulnerable, and we're tied to its fate in ways that become more dangerous the more we understand. Asteroids cross Earth's orbit constantly. Most are small, burning up in the atmosphere, but larger ones hit periodically, and when they do, the consequences are catastrophic. 66 million years ago, an asteroid about 10 kilometers wide struck the Yucatan Peninsula. The impact energy exceeded all nuclear weapons ever built by a factor of thousands. Debris ejected into the atmosphere blocked sunlight for years. Temperatures plummeted. Ecosystems collapsed. 75% of species died, including every dinosaur larger than a chicken. The dinosaurs had no warning, no technology, no means of deflection or escape. When their world ended, they ended with it. And for millions of years afterward, Earth belonged to small mammals that survived by being unimportant enough to escape notice during the catastrophe. We're not dinosaurs. We can detect asteroids, track their orbits, potentially deflect them given enough warning. But detection isn't perfect, and deflection technology remains theoretical. An asteroid could arrive with little warning, too large to stop, and end our civilization as thoroughly as the dinosaurs ended. Not destroy the planet Earth would recover, life would persist, evolution would continue, but humanity, all we've built and learned and become, would vanish. This isn't distant speculation. In 2013, a meteor exploded over Chelyabinsk, Russia. 20 meters wide, it released energy equivalent to 500 kilotons of TNT. Windows shattered across the region. Over 1,000 people were injured, and we never saw it coming. It approached from the direction of the sun, where telescopes can't look, and we had zero warning before impact. That was small, a city killer, not a civilization ender. But it proves the vulnerability. Earth exists in a cosmic shooting gallery, and eventually, statistically, certainly, something large enough to cause global catastrophe will arrive. Maybe in 1,000 years, maybe 10,000, maybe tomorrow. We don't know, can't predict, and have no guarantee of survival. Then there are the threats we create ourselves. Climate change, nuclear weapons, engineered pathogens, artificial intelligence gone wrong. We're developing capabilities to destroy ourselves long before asteroids become statistically likely. The 20th century proved we'll use such capabilities. We detonated nuclear weapons in warfare. We came within moments of global thermonuclear war during the Cuban Missile Crisis. We're currently altering Earth's climate despite knowing the consequences. A single planet species is fragile in ways that become horrifying once you recognize them. One asteroid, one supervolcano, one runaway pandemic, one nuclear exchange, any of these could end us. Not necessarily kill every human, but collapse civilization so thoroughly that recovery becomes impossible, leaving survivors without technology or knowledge or resources to rebuild. This is the eggs in one basket problem. As long as humanity exists only on Earth, we're vulnerable to any catastrophe that affects Earth, and Earth is not stable. It's geologically active, orbiting in a dangerous region of space, hosting a species capable of self-destruction. Staying here forever guarantees eventual extinction. Not might guarantee, does guarantee. Eventually something will happen that ends us. Going to space solves this. Not easily, not quickly, but solvable. Establish a self-sustaining settlement on Mars, and humanity becomes a two-planet species. No single catastrophe can end us anymore. Earth could be destroyed, and humans would persist. Mars could fail, and Earth remains. Both would have to fail simultaneously, which is far less likely than either failing individually. Add the Moon, Venus, orbital habitats, asteroid settlements. Each one decreases extinction risk further. Spread across the solar system, humanity becomes robust against catastrophes. Spread across multiple star systems, we become nearly inextinguishable. The universe would have to work very hard to eliminate us completely. This is why Artemis matters. Not Artemis II specifically, that's a test flight, proving systems, training crews, but the program. Artemis leads to permanent moon bases, to resource utilization, to learning how to live off Earth sustainably. The moon becomes a laboratory for Mars, and Mars becomes the second basket for humanity's eggs. We're not doing this fast enough. Years pass between missions. Budgets fluctuate. Political priorities shift. Meanwhile, the threats accumulate. Every year we remain a single planet species is another year we could end. Not will end, but could. And the probability, while small annually, becomes significant over centuries. The Artemis 2 crew will orbit the moon, see Earth from a distance, and return home. They're not staying, not building bases, not establishing permanent presence. But they're proving we can leave Earth's immediate vicinity, can venture into deep space, can survive conditions humanity hasn't experienced in half a century. They're testing systems that will eventually carry others farther, to lunar bases, to Mars, to destinations we haven't named yet. Because we have to. Because the alternative is waiting here until something ends us. Because being a single planet species is the most dangerous situation our species has ever faced, and the only solution is spreading beyond this world. Earth is home, beautiful, precious, irreplaceable. We should protect it, preserve it, solve the problems we've created here. But we should also leave it, not abandoning it, but complementing it, making sure that if Earth fails, humanity doesn't fail with it. We go to space because we must, because survival demands it, because keeping all our eggs in one basket is gambling with extinction, and the stakes are everything every future human who might exist, every discovery they might make, every moment of consciousness they might experience. We owe them the chance to exist, and that means going to space, spreading out, ensuring that no single disaster can end the story. There's a moment in childhood when you first look up and realize the stars are distant suns, not decorations, not lights in a sky dome, but objects like our sun, unimaginably far away, each possibly hosting worlds of their own. For some people, that realization passes quickly, interesting but not compelling. For others, it never lets go. The knowledge that there are places out there, real places, unreachable but existing, it creates hunger. This hunger isn't rational. It doesn't calculate costs versus benefits or weigh practical returns. It's primal, almost instinctive, the same drive that made our ancestors climb the next hill, not knowing what lay beyond, cross oceans without maps, venture into territories where they might die, but might discover something extraordinary. We explore because we're curious. That's the simple answer, and it's sufficient. Human beings wonder. We see boundaries and want to know what lies beyond. We encounter mysteries and need to solve them. We're told something is impossible and immediately start figuring out how to do it anyway. This isn't unique to certain individuals. It's species-wide, coded somehow into human nature at a fundamental level. Look at history. Every habitable region of Earth has been explored, settled, inhabited. Our ancestors spread from Africa to every continent, crossing mountains and deserts and oceans that should have been impassable. They didn't spread because resources were depleted. They spread while resources remained abundant, driven by something other than necessity. They spread because humans explore. It's what we do. The Pacific Islanders are extraordinary examples. Starting from Southeast Asia, they populated islands across the Pacific using outrigger canoes and navigation techniques based on stars, waves, and bird behavior. They reached Hawaii, Easter Island, New Zealand voyages spanning thousands of kilometers of open ocean, no land visible for days or weeks, no guarantee of finding anything, just heading toward where they thought islands might be. Why? Why risk everything crossing an ocean when you have a perfectly good island already? Because the ocean was there. Because the horizon suggested something beyond it. Because humans see frontiers and cross them even when crossing makes no practical sense. even when staying would be safer and easier and more rational. This drive intensified with technology. Ships improved, allowing longer voyages. Navigation techniques developed. Maps accumulated knowledge, revealing what lay beyond horizons, which only created new horizons farther out. The age of exploration wasn't driven primarily by resources or conquest. Those came later, justifications after the fact. The initial drive was simpler: wonder, curiosity, the need to know what was out there. Space is the ultimate expression of this drive. The moon hangs in the sky, visible, tantalizingly close by cosmic standards. Mars shines red in the evening. Jupiter and Saturn glow steadily, while stars beyond number scatter across the darkness. We've looked at these for all of human history, wondered what they are, created myths and stories and scientific theories trying to understand. And now we can reach them. Not easily, not cheaply, but reachably. The moon is 3 days away. Mars is months. The outer planets are years, but achievable with current technology given sufficient will and resources. They're not unreachable. They're just hard to reach. And humans have never let difficulty stop us from exploring. The Artemis II crew embodies this. They're going to the moon not because humanity desperately needs something the moon provides, but because the moon is there and we can reach it. The mission will conduct science, test systems, gather data, but fundamentally it's exploration. It's humans going somewhere we haven't been in 50 years because we're curious, because we wonder what's there, because not going is intolerable once going becomes possible. This curiosity has practical benefits. Exploration discovers resources, identifies opportunities, reveals dangers. The Vikings exploring North America found abundant resources. The Polynesians settling remote islands discovered rich fishing grounds. Columbus reaching the Americas despite thinking he'd reached Asia opened up continents that transformed world history. But those benefits are retrospective. They happened because exploration happened, not the other way around. The explorers didn't know what they'd find. They went anyway, driven by curiosity, by ambition, by the simple human inability to see a frontier without crossing it. Space exploration follows this pattern. We don't know what we'll find. Maybe Mars hosted ancient life. Maybe Europa's oceans contain organisms. Maybe there's nothing, just sterile rock and ice and vacuum. But we won't know until we look, and not looking is unbearable to the curious mind. This curiosity creates knowledge that transforms civilization. Astronomy developed from wondering about celestial objects. Physics advanced through understanding orbits, gravity, relativity, all driven by curiosity about the cosmos. Technology progressed as we built tools to explore, each one revealing more, creating new questions, driving further exploration. Going to space continues this. Every mission reveals something unexpected. Every discovery raises new questions. The more we learn, the more we realize how little we know. And that expanding boundary of ignorance is exciting rather than frustrating, because it means more to explore, more to discover, more opportunities for wonder. The Artemis program will reveal things we can't predict. Maybe lunar ice contains clues about Earth's early history. Maybe Gateway, the planned lunar station, enables observations impossible from Earth orbit. Maybe techniques developed for lunar exploration prove crucial for Mars or asteroid missions. We don't know yet. We're going to find out. And beyond practical benefits, there's the pure joy of discovery. The first time a human sees Earthrise from lunar orbit, that experience has value regardless of practical application. The moment someone stands on Mars, looks at the landscape, and realizes they're the first life from Earth to touch that world, that's meaningful in ways that transcend utility. We're curious creatures. We wonder, question, explore. We see mysteries and need to solve them. We encounter boundaries and feel compelled to cross them. This has driven human progress for millennia, pushing us from caves to cities, from stone tools to spacecraft, from wondering about stars to visiting them. Space is where curiosity leads now. The moon, Mars, asteroids, the outer planets, they're out there, reachable, full of mysteries we can solve if we're willing to try, and we are willing. We've always been willing. Curiosity doesn't calculate. It drives. And it's driving us to space, one mission at a time, one discovery after another, following the same impulse that made our ancestors climb hills and cross oceans and wonder what lay beyond every horizon they encountered. We go because we're curious, because mysteries exist and we need answers, because frontiers call to us and we cannot resist, because wonder is part of being human, and space offers wonder in quantities we've barely begun to experience. In 1968, Apollo 8 became the first crewed mission to orbit the moon. 3 astronauts, Frank Borman, Jim Lovell, Bill Anders, left Earth, circled the moon 10 times, and returned. The mission accomplished its objectives, proving systems, testing procedures, photographing potential landing sites for future missions. But the most important thing Apollo 8 brought back wasn't data. It was a photograph. Bill Anders pointed his camera at Earth rising above the lunar horizon. The planet appeared as a small blue and white sphere against the black void of space, fragile, beautiful, isolated. Continents were visible, clouds swirling, oceans reflecting sunlight, and around it, nothing. Just darkness extending infinitely in all directions. This image, Earthrise, changed how humans see their world. Not scientifically, not in terms of data or measurements, emotionally, psychologically. It revealed Earth not as the center of everything, not as a vast and inexhaustible resource, but as a small, fragile oasis in a hostile universe. Everything humans had ever done, every war and achievement and moment of history happened on that small sphere. All of it, and the sphere hung there, alone, vulnerable, precious beyond measure. The astronauts who've seen Earth from space report similar experiences. The boundaries that seemed so important from the ground, nations, borders, political divisions, become invisible. From orbit, you can't see countries. You see one world, one ecosystem, one atmosphere that all humans share. The artificial divisions we fight over vanish, replaced by recognition of our fundamental unity as one species on one planet. They call this the overview effect. It's not simply seeing Earth from space. It's having your perspective shifted so dramatically that you can't unsee what you've realized. Earth is home, but it's also tiny, isolated, the only habitable world in a vast and empty cosmos. We're not separate nations competing for dominance. We're one species, one family sharing one fragile home that we need to protect because there's nowhere else to go. Many astronauts become environmental activists after returning to Earth, not because space travel made them care about the environment, but because seeing Earth from outside made them understand viscerally what intellectually they already knew, that the planet is finite, delicate, easily damaged by careless treatment. The thin blue line of atmosphere that makes life possible is visibly thin from space, fragile as a soap bubble, the only thing between life and the lethal vacuum beyond. Others become advocates for peace. Seeing Earth without borders makes the conflicts that divide humans seem absurd. Fighting over territory, resources, ideological differences from space. These conflicts look like family arguments, petty squabbles on a scale too small to matter cosmically, but desperately important to the people involved. The perspective doesn't erase the conflicts, but it recontextualizes them, makes them seem solvable rather than fundamental, human-created rather than inevitable. This perspective is valuable beyond what any individual astronaut experiences. The photographs they bring back, the descriptions they provide, the interviews where they struggle to articulate what seeing Earth from space felt like. These reach millions of people who will never leave the planet, but who can participate vicariously in that shifted perspective. Earthrise helped inspire the environmental movement. The image appeared on posters, magazines, books. It became iconic, representing not just an achievement of space exploration, but a new way of seeing our world. The first Earth Day happened in 1970, partly motivated by the recognition that we're all sharing one planet that we need to take care of. The image didn't create environmentalism, but it provided a powerful visual representation of what environmentalists had been saying. Earth is finite, interconnected, precious, and in need of protection. The Artemis II crew will experience this. They'll see Earth from lunar distance, watch it shrink as they travel outward, see it as astronauts have described, a small blue marble in vast darkness. And they'll return changed, carrying that perspective back, sharing it through photographs and interviews, and the subtle ways that transformative experiences alter how you interact with the world. But Artemis offers something beyond individual transformation. It's returning humans to deep space after 50 years. An entire generation has grown up knowing space exploration primarily through robots, satellites, space stations, and low Earth orbit. The moon became history, something their grandparents accomplished, not a place humans actively explore. Artemis changes this. It makes the moon current, again relevant, a destination humans are visiting now, rather than 50 years ago. And with that currency comes renewed perspective. New images of Earth from lunar orbit. New descriptions of what it feels like to see your planet from 250,000 miles away. New opportunities for people who weren't alive during Apollo to experience vicariously what that generation experienced. This matters because perspective is cumulative. The more people who experience overview effect, even vicariously, the more that perspective influences human culture, politics, decision-making. One astronaut seeing Earth from space affects dozens of people directly through personal interactions and thousands indirectly through media. Dozens of astronauts affect millions. Make space travel common enough, and eventually the perspective becomes mainstream, shifts from rare revelation to common understanding. We're not there yet. Space remains expensive and difficult, accessible to tiny numbers of highly trained individuals. But Artemis is a step. Gateway, the planned lunar station, will host more astronauts for longer periods. Lunar bases, when they exist, will house dozens or eventually hundreds. Mars missions will carry crews who'll see Earth not as a marble, but as a point of light barely distinguishable from other stars. Each of these steps spreads the perspective wider, makes it more common, embeds it more deeply in human consciousness. and that perspective recognition of Earth's fragility, acknowledgement of our unity, understanding that we're one species sharing one world might be as important as any technological or scientific benefit space exploration provides, because most of humanity's problems are problems of perspective. We treat the environment as infinite because locally it seems infinite. We fight wars over borders because from the ground those borders seem real and important. We divide ourselves by nation, religion, ethnicity because those divisions feel fundamental rather than arbitrary. Seeing Earth from space doesn't erase these problems. It doesn't make environmental damage disappear or end wars or eliminate divisions, but it changes how we see them. It provides context that makes solutions more conceivable, makes cooperation more attractive, makes the idea of one planetary civilization seem natural rather than utopian. This is why photographs from space are powerful. They're not just pretty pictures. They're reality checks, reminders of what our planet actually is, a small, finite, beautiful world in an enormous and mostly empty cosmos, the only home we have, worthy of protection and care and cooperation, because we're all in this together, whether we recognize it or not. We go to space for perspective, to see Earth as it actually is rather than how it appears from the surface, to gain understanding that can only come from stepping outside, looking back, recognizing what we're part of. The overview effect isn't the goal of space exploration, but it might be the most important benefit, a shift in consciousness that could, if spread widely enough, help solve problems that seem intractable from ground level but obvious from orbital altitude. The Artemis 2 crew will bring back photographs. They'll give interviews, describe what they saw, try to convey the experience of seeing Earth as a small sphere in darkness. And millions of people will see those images, hear those descriptions, and participate in that perspective shift. Not as fully as the astronauts themselves, but enough. Enough to change how they think about the planet, about humanity, about our place in the cosmos. That's worth going for. That alone might justify the cost. There are questions that haunt us. Not practical questions with clear answers, but fundamental ones that touch on existence, meaning, our place in reality. Questions that philosophers have debated for millennia, that religions have answered in different ways, that science is only beginning to address properly. Are we alone in the universe? How did life begin? Is Earth special, or is life common? What are the conditions that allow consciousness to emerge? Are there other intelligences out there, wondering the same things we wonder, asking the same questions? These questions matter not because the answers have immediate practical applications, but because they define how we see ourselves. If we're alone, unique, the only consciousness in a vast, dead universe, that means something about what we are and what our responsibilities might be. If we're not alone, if life is common and intelligence arises frequently, that means something else entirely about our place in the cosmos. For most of history, we couldn't investigate these questions empirically. We could philosophize, theorize, believe, but we couldn't test. Earth was all we had access to, all we could study directly. The stars were unreachable, distant lights whose nature remained mysterious despite millennia of observation. Space exploration changed this. Not immediately, not completely, but fundamentally. We can now send instruments to other worlds, examine their geology and chemistry, search for signs of life or conditions that support it. We can analyze atmospheres of planets orbiting other stars, looking for biosignatures, oxygen, methane, combinations of gases that suggest biological activity. We can't visit those planets yet, can't study them directly, but we can detect them, characterize them, begin understanding how common Earth-like worlds actually are. And the answer is startling. They're everywhere. Thousands of exoplanets have been discovered, with more found constantly. Many orbit in their star's habitable zone where temperatures allow liquid water. Some have atmospheres. Some show chemical signatures suggesting geological activity. We don't know if any host life, but the conditions that allowed life on Earth aren't unique. They're common throughout the galaxy. This doesn't prove life is common. Conditions that allow life might be necessary but not sufficient. Maybe life emerging from chemistry requires such improbable coincidences that Earth's biosphere is unique despite billions of potentially habitable worlds. But it suggests life might not be rare. It opens the possibility that when we look closely enough at other worlds, we might find something extraordinary, evidence that we're not alone. Mars is the most accessible target for this search. 4 billion years ago, Mars had liquid water on its surface, a thicker atmosphere, possibly conditions similar to early Earth. Life might have emerged there the same way it emerged here. And if it did, traces might remain: fossil microbes and ancient sediments, chemical signatures in rocks, maybe even surviving organisms in subsurface environments where liquid water still exists. Rovers have found evidence that Mars once had habitable conditions. River channels, lake beds, minerals that form in water. The geological record shows a warmer, wetter ancient Mars. Whether life actually existed is unknown. The rovers we've sent so far aren't designed to definitively detect life, only to study geology and characterize environments. But they've proven that habitable conditions existed, which makes the question of whether life actually arose much more than speculation. Artemis eventually connects to this. Not directly. The moon is too hostile for life, too radiation exposed, too temperature extreme, lacking water or atmosphere. But the moon is a testing ground for Mars. Technologies developed for lunar exploration habitats, life support, or resource utilization will be refined and deployed on Mars. Artemis 2 tests deep space systems that Mars missions will require. Gateway will host experiments and serve as a staging point. The moon is practice for the bigger goal, and that bigger goal includes searching for life. Future Mars missions will carry instruments specifically designed to detect biosignatures, drill into subsurface environments, analyze samples for organic molecules and cellular structures. If life existed on Mars, even in the distant past, we have a chance of finding it. Finding life on Mars would be transformative. Not practically. Martian microbes won't cure diseases or solve problems, but philosophically, it would prove life arises on multiple worlds, that the chemistry leading to biology isn't unique to Earth, that the universe contains not one biosphere, but at least two. And if two, then probably millions or billions, because the conditions that allowed life on Earth and Mars aren't special, they're common throughout the galaxy. This changes the question from "are we alone?" to "how common is life?" and from there to "how common is intelligence?" If life arises easily wherever conditions allow, then the universe might be full of biospheres, each evolving, adapting, possibly producing consciousness. We might not be alone. We might not even be unusual. Intelligence might be something the universe does, a natural consequence of chemistry and evolution and sufficient time. Or maybe not. Maybe life is common but intelligence is rare. Maybe consciousness requires such specific conditions, such improbable evolutionary paths, that Earth's biosphere is the only place it's happened in the observable universe. The answer matters enormously, but we don't know it yet. We can't know it sitting on Earth speculating. We have to go look. Europa, one of Jupiter's moons, has an ocean beneath its icy surface. The ice is thick kilometers, but beneath it lies liquid water kept warm by tidal heating from Jupiter's gravity. This ocean is larger than all of Earth's oceans combined, and where there's liquid water, there might be life. We don't know if Europa's ocean is habitable. It's dark, no sunlight penetrates the ice. It might be too salty, too cold, too chemically hostile. But Earth has life in extreme environments, hydrothermal vents, deep caves, ice-covered Antarctic lakes. If life can exist in those places, maybe it can exist in Europa's ocean. Maybe it's there right now, organisms adapted to darkness and cold, thriving in an environment utterly alien to surface Earth, but perfectly suited to their biochemistry. Enceladus, a moon of Saturn, also has a subsurface ocean. We know because geysers erupt from its south pole, spraying water into space. Cassini flew through these plumes, analyzed their chemistry, found organic molecules, carbon compounds that might be food for life, or might be produced by life. We don't know which, but the presence of liquid water and organic chemistry makes Enceladus another target in the search for life beyond Earth. Titan, Saturn's largest moon, has lakes and seas. Not water, it's too cold, but liquid methane and ethane, hydrocarbons in liquid form. Titan's atmosphere is thick nitrogen with organic haze, chemistry similar to early Earth, but at temperatures where water is rock hard and methane is liquid. Could life exist in such conditions? Not life as we know it, but maybe something different, organisms using different chemistry, adapted to conditions we'd find impossible. We don't know. We're speculating based on limited data. But that's the point. We don't know, and the only way to find out is to go there, send instruments, analyze environments directly. Speculation has limits. At some point you need data, and getting data from other worlds requires going to those worlds. The Artemis program doesn't directly address these questions. The moon is dead, geologically and biologically. But Artemis develops capabilities we need for missions that will address them. Learning to live on the moon teaches us how to live on Mars. Gateway as a lunar station is prototype for deep space habitats. Technologies developed for Artemis will be adapted for missions to Europa, Enceladus, Titan, places where the search for life becomes realistic rather than speculative. And beyond searching for life, there's understanding life itself. How does chemistry become biology? What conditions are necessary and sufficient? Is Earth's biochemistry, DNA, proteins, cellular structures the only way, or one way among many? If we find life on Mars or Europa, and it uses different biochemistry, that tells us something profound about what life is fundamentally, about the range of possibilities that chemistry allows. These questions matter because they define what we are. If life is common, if intelligence arises frequently, then we're part of something larger, a universe that generates consciousness repeatedly, maybe inevitably. Our questions aren't unique. Others are asking them. And possibly some have found answers, reached conclusions, achieved understandings we're only beginning to glimpse. If we're alone, if life is rare and intelligence even rarer, then we're precious beyond measure. We might be the universe's only way of understanding itself, consciousness arising once in trillions of stars, unique not just in fact, but possibly in principle. That means we have responsibilities to preserve ourselves, protect Earth, ensure that consciousness persists, because if we fail, the universe returns to unconsciousness. We don't know which is true. We can estimate probabilities, make arguments, cite Drake equation calculations, suggesting life should be common or rare, depending on which parameters you use. But estimates aren't answers. Arguments aren't data. We need to go look, search systematically, examine other worlds directly. The Artemis 2 crew isn't searching for life. They're orbiting the moon, testing systems, proving capabilities. But they're part of a larger program that leads toward those searches, that develops technologies and experience and infrastructure needed for missions that will, eventually, visit places where life might exist or have existed. We go to space to answer questions. Not all of them. Some questions are philosophical, requiring thought rather than exploration. But the questions about life, about our place in the cosmos, about whether we're alone, these require data that only space exploration can provide. We need to examine other worlds, analyze their chemistry, search for biosignatures or fossils or living organisms. We need to study planetary formation, understand conditions that allow life, characterize the frequency of habitable worlds. These aren't idle curiosities. They're fundamental questions about existence, consciousness, meaning. And the only way to answer them is to go to space, explore systematically, gather data from multiple worlds, build understanding from empirical evidence rather than speculation. So we go, not just to the moon, though the moon is current target, eventually to Mars, to asteroids, to the outer planets and their moons, to places we can barely imagine reaching, but that technology and persistence will eventually make accessible. We go because questions exist that can only be answered through exploration, mysteries that require data, uncertainties that demand resolution. And when we find answers, whether they confirm we're alone or reveal we're surrounded by life, those answers will change everything. Not just scientifically, but philosophically, culturally, spiritually. Understanding our place in the cosmos will reshape how we see ourselves, how we value Earth, how we think about our responsibilities and possibilities and future. We go to answer questions, and the answers, when we find them, will be worth every difficulty, every cost, every risk we accept to get them. In 1962, President Kennedy gave a speech at Rice University. The United States was losing the space race. The Soviet Union had launched the first satellite, sent the first human to orbit, achieved milestones that made American efforts seem inadequate. Political pressure mounted to abandon expensive space programs, focus on terrestrial problems, except that maybe Americans wouldn't lead in this domain. Kennedy said something that became iconic. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard, not in spite of difficulty, because of it. This seems counterintuitive. Why deliberately choose hard tasks? Why not pick easy goals, maximize success, avoid risk? But Kennedy understood something fundamental about human nature. Difficulty creates meaning. Easy achievements satisfy briefly, but don't transform. Hard achievements, things that require pushing limits, developing capabilities, overcoming obstacles. These change who we are in the process of accomplishing them. Climbing a mountain isn't valuable because of what's at the summit. It's valuable because of what climbing requires: preparation, persistence, dealing with discomfort and danger, and the constant temptation to quit. Reaching the top matters, but the transformation happens during the climb. Who you become through achieving difficult goals is more important than the achievement itself. Apollo succeeded because it was hard. Engineers faced problems that had never been solved: rocket staging, orbital rendezvous, landing on another world, life support in vacuum. Each problem required innovation, creativity, attempts that failed before finding solutions that worked. The difficulty forced development of new technologies, new techniques, new ways of thinking about problems. Many of those technologies became foundational for modern life. Integrated circuits, advanced materials, computer systems, all developed or refined through Apollo. Not because anyone planned to create these civilian technologies, but because solving the hard problems of spaceflight required innovations that proved useful in other contexts. Medical technology benefited enormously. Miniaturization needed for spacecraft instruments led to portable medical devices. Water purification systems for astronauts became systems for remote areas without clean water. Freeze-dried food preservation, infrared ear thermometers, scratch-resistant lenses all emerged from technologies developed for space. But beyond specific technologies, Apollo changed how we approach complex problems. Managing hundreds of thousands of people working toward a single difficult goal required organizational innovation, systems engineering, project management techniques, quality control processes. These became standard across industries, improving efficiency and reliability in domains far removed from space exploration. The difficulty also united people. Not everyone supported Apollo. Critics argued the money should go to poverty, education, healthcare, but those who supported it felt part of something larger than themselves, a national effort to achieve something impossible, to prove human capability by doing what had never been done. The difficulty made it meaningful. If it had been easy, no one would have cared. Artemis faces similar challenges. Going to the moon isn't as difficult now as it was 60 years ago. We understand the problems, have better technology, can learn from Apollo's successes and failures, but it's still hard. Rockets still fail occasionally. Life support remains complex and fragile. Radiation exposure is dangerous. Operating far from Earth with communication delays and limited abort options means accepting risks that would be unacceptable in normal circumstances. And that difficulty matters. It forces innovation. Gateway, the planned lunar station, requires technologies Apollo never needed: long duration, deep space life support, radiation shielding, reliable systems that operate for years rather than days. Developing these technologies will be difficult, but the difficulty drives innovation that will benefit missions beyond Gateway, systems that enable Mars missions and asteroid exploration, and eventually journeys to the outer planets. The moon itself presents challenges. Lunar dust is abrasive and statically charged, sticking to everything, infiltrating seals, damaging equipment. Extreme temperature swings from boiling hot in sunlight to hundreds of degrees below freezing and shadow stress materials in ways Earth environments don't. Long lunar nights last 14 Earth days, requiring power systems that function without sunlight for extended periods. Solving these problems is hard, but solutions will work elsewhere. Dust mitigation techniques for the moon will help on Mars, where dust storms can last months. Power systems for long lunar nights will enable exploration of permanently shadowed craters on Mercury or operation in the outer solar system where sunlight is weak. Temperature-resistant materials developed for the moon will function in any extreme environment we encounter. This is why difficulty is valuable. Easy problems have obvious solutions that don't generalize. Hard problems force creative solutions that work in multiple contexts, technologies that prove useful beyond their original purpose. Apollo's difficulty led to innovations that transformed civilian technology. Artemis's difficulty will do the same, developing capabilities that enable not just lunar exploration, but the entire next phase of space development. There's also something about hard goals that attracts exceptional people. Easy problems draw competent individuals who can solve them routinely. Hard problems draw the best people who want challenges, who feel driven to tackle impossibilities, who find meaning in pushing limits. Apollo attracted brilliant engineers, talented managers, creative problem solvers, who might have worked on other projects but were drawn specifically by the difficulty. Artemis does the same. The engineers designing Orion, the astronauts training for missions, the mission planners figuring out operations, they're there partly because it's hard, because being part of something difficult and important provides meaning that routine work can't match. And the difficulty inspires others. Watching people achieve hard goals makes you believe you can achieve difficult things too. Apollo inspired an entire generation to pursue science and engineering, not because space seemed easy, but because it seemed hard, and people were doing it anyway. Students watched launches, followed missions, saw humans do impossible things, and thought, I want to be part of that. Artemis can inspire similarly. A generation has grown up with space being routine satellites, space station, robotic probes. Impressive, but not impossible feeling. Artemis changes this by going farther, attempting missions that feel daring, showing that space exploration isn't finished, but expanding. The difficulty makes it exciting. If it were easy, it would be boring. Kennedy understood this intuitively. We choose to go to the moon because it is hard wasn't just rhetoric. It was recognition that human beings need challenges, that we're most alive when stretching toward difficult goals, that meaning comes not from comfort but from struggle. Space provides endless difficulty. The distances are vast. The environments are hostile. The engineering challenges are extreme. Nothing about space exploration is easy, and it probably never will be. Even when we've established lunar bases and Mars colonies and asteroid settlements, those places will remain challenging, requiring constant effort to maintain, expand, improve. And that's good, because difficulty is what drives progress. Comfort leads to stagnation. When everything is easy, there's no pressure to innovate, no reason to develop new capabilities, no motivation to push boundaries. Difficulty creates pressure, forces adaptation, rewards innovation. We go to space because it's hard, because the difficulty forces us to be better, smarter, more capable, more innovative than we'd be otherwise. Because achieving hard goals transforms us in ways easy achievements never do. Because humanity thrives on challenges, needs frontiers, requires difficult problems to solve in order to feel fully alive. The Artemis 2 crew will face challenges. Systems might malfunction. Procedures might need adjustment. Unexpected problems might arise. This is inherent in doing difficult things, especially things that haven't been done recently. But overcoming those challenges, solving problems in real time, adapting to situations that simulations didn't predict, that's where growth happens. That's where capability develops. That's where human beings prove what we can do when challenged. And that proof matters, not just for national pride or program justification, but for human self-understanding. We need to know we can do hard things, that difficulty doesn't stop us, that challenges inspire rather than intimidate. Going to space because it's hard reminds us that we're capable of far more than comfort and routine suggest. It proves that when we're pushed, we push back, finding solutions and building capabilities and achieving things that seemed impossible before we tried. So we choose to go, not despite the difficulty, but because of it. Because hard goals make us better. Because challenges drive innovation. Because doing impossible things is what human beings do best. What defines us? What makes us proud of what we've achieved and excited about what we might achieve next? Earth is finite. This isn't opinion or speculation, it's physical fact. The planet has a certain amount of metal, rare elements, chemical compounds. We're using these resources at rates that would have seemed impossible a century ago. And while some are renewable on human timescales, many aren't. Once extracted and used, they're gone or so dispersed that recovery becomes impractical. This creates pressure, not immediate crisis. We're not running out tomorrow, but long-term trends are concerning. Rare earth elements essential for electronics, platinum group metals for catalysts in fuel cells, helium for superconductors and medical imaging, all face supply constraints. Prices rise. Geopolitical tensions increase as nations compete for access. And meanwhile, we're using more, not less, as technology spreads and populations grow. The traditional solution is finding new deposits, improving extraction efficiency, developing substitutes. These work temporarily but don't address the fundamental problem. Earth's resources are limited, and we're using them faster than geological processes can replenish them. Space offers a different solution. Not unlimited resources, nothing is truly unlimited. But resources on scales that make Earth's deposits seem almost negligible by comparison. Asteroids containing more platinum than has ever been mined on Earth. The Moon with helium-3 that could fuel fusion reactors for millennia. Mars with minerals and metals comparable to Earth's entire crust. The resources exist. The challenge is accessing them. And that challenge is becoming solvable. Not easily, not cheaply, but solvable in ways that would have been impossible decades ago. Reusable rockets reduce launch costs. Robotic mining technology advances rapidly. Power systems using solar energy or nuclear generators can operate anywhere sunlight reaches. The engineering problems remain hard, but they're being worked on, solutions developing, capabilities improving. Consider asteroids. Thousands cross Earth's orbit or reside in the asteroid belt between Mars and Jupiter. Most are rocky, similar to terrestrial minerals, but some particularly metallic asteroids contain enormous concentrations of valuable elements. Iron, nickel, platinum, gold, rare earth elements, all in purities and quantities that dwarf Earth's richest deposits. One asteroid, 16 Psyche, is believed to be mostly metal, possibly the exposed core of a protoplanet that lost its rocky mantle through ancient collisions. Current estimates suggest its metal content is worth more than the entire global economy. Not that bringing it all back would be economically rational. Flooding markets with that much material would collapse prices, but even a fraction would supply Earth's needs for decades or centuries. Mining asteroids isn't science fiction anymore. Multiple companies are developing technologies, robots that can attach to asteroids, drill, extract materials, processing equipment that uses solar furnaces to separate metals from rock, transportation systems that can move refined materials to Earth orbit or lunar bases, where they're more useful than on Earth's surface, where lifting them back to orbit would be expensive. The moon offers different resources. Not metals, particularly lunar composition is similar to Earth's crust. But helium-3, an isotope rare on Earth but relatively abundant in lunar regolith, deposited by solar wind over billions of years. Helium-3 could fuel fusion reactors, providing clean energy without the radioactive waste of current fission designs. We don't have working fusion reactors yet, but when we do, helium-3 becomes incredibly valuable. The moon also has water ice and permanently shadowed craters near the poles. Water is heavy, expensive to launch from Earth, but water on the moon can be extracted, purified, used for life support, or split into hydrogen and oxygen for rocket propellant. A moon base with local water becomes far more viable than one dependent on Earth resupply, and lunar water can support missions elsewhere. Refueling stations in lunar orbit make trips to Mars or asteroids more practical by not requiring all fuel to be lifted from Earth. Artemis specifically targets these resources, not extraction immediately. The early missions are exploration and base construction, but Gateway will orbit the moon, allowing easier access to the surface. Artemis base camps near the lunar poles will investigate ice deposits, test extraction techniques, prove that resources can be used locally. These aren't just scientific experiments. They're demonstrations of industrial processes that could eventually supply Earth or support deeper space missions. Mars has resources too. The atmosphere is mostly carbon dioxide, useful for making methane fuel and oxygen. The soil contains water ice, particularly at high latitudes. Minerals are available for construction and manufacturing. A Mars colony couldn't depend entirely on local resources initially, but eventually it could produce most of what it needs, reducing dependence on expensive Earth resupply. This matters because Earth's resource constraints are real, not crisis level yet, but worsening. We can reduce consumption, improve efficiency, recycle more aggressively, and we should. But even with perfect efficiency, growth means using more resources, and humans are increasing in number and wealth, both trends driving higher consumption. Space resources don't solve everything, but they relieve pressure. Mining asteroids means not mining Earth, preserving terrestrial environments while still accessing needed materials. Using solar power stations in space means not burning fossil fuels. Helium-3 from the moon could provide clean energy without climate impact. And critically, space resources enable space development. Building habitats, spacecraft, infrastructure in orbit using materials launched from Earth is prohibitively expensive. But building them from asteroid metal or lunar materials makes economic sense because those materials are already in space, no gravity well to escape. This creates a positive feedback loop. Space resources make space development cheaper, which enables accessing more space resources, which makes further development cheaper still. The Artemis program isn't primarily about resources, but it develops capabilities that resource extraction requires. Learning to live on the moon teaches lessons applicable to asteroid mining. Gateway as infrastructure demonstrates that humans can work in deep space long-term. Technologies developed for lunar ice extraction will work on asteroid volatiles or Martian ice. Some argue we should solve Earth's problems before pursuing space resources, but these aren't separate. Space development creates technologies that help Earth solar panels, water purification, recycling systems, all improved through space applications. And relieving resource pressure through space resources helps solve terrestrial problems by reducing environmental destruction from mining and extraction. There's also a timing issue. Developing space resource capabilities takes decades. We can't wait until Earth's resources are exhausted before starting by, then it's too late. The industrial base needed to build space infrastructure might not exist anymore. We need to develop capabilities now while we still have resources to invest, creating systems that can eventually relieve pressure before that pressure becomes crisis. This isn't exploitation for profit alone, though economic motivations matter. It's recognition that finite resources plus growing demand equals eventual shortage unless we expand the resource base. Earth's minerals and materials came from space, originally asteroids and comets, delivering elements during planetary formation. We're not finding alien resources. We're accessing the same materials that built Earth, just still in their original locations, instead of already accumulated in one planet. And there's responsibility. If we can access resources in ways that don't harm environments, mining asteroids doesn't destroy ecosystems because asteroids don't have ecosystems, then not doing so, while instead tearing up Earth, seems almost unethical. We have technological capability emerging. Using it responsibly means relieving pressure on Earth while meeting human needs. The Artemis II crew won't be mining anything. They're testing systems, proving capabilities, demonstrating that humans can work in deep space. But their mission enables others who will investigate resources, develop extraction technologies, build infrastructure. The path from Apollo to Artemis took 50 years. The path from Artemis to industrial space development might take another 50. But it starts now with missions like Artemis II, proving we can return to deep space, stay there, work there, eventually live there. We'd go to space for resources, not because Earth is exhausted, but because space offers alternatives that reduce pressure, enable growth without environmental destruction, provide materials on scales that make current supply constraints irrelevant. The engineering is hard, the timeline is long, the investment is substantial, but the potential return, sustainable resource access, environmental protection, economic expansion justifies effort. Resources aren't the only reason we go to space, but they're a compelling one, increasingly relevant as Earth's limitations become more apparent. Space isn't escape from planetary limits. It's expansion of what's available, growth of the resource base, access to materials that exist in vast quantities just beyond our current reach, and reaching for them, learning to use them, building industries that operate in space and relieve pressure on Earth. That's part of becoming a spacefaring civilization, a species that doesn't depend on one planet's finite endowment, but can draw from the much larger reservoir surrounding us. There's a reason children want to be astronauts. Not all children, some want to be doctors, teachers, artists, but enough that astronaut remains one of the most common aspirations, even among kids who've never seen a launch, who live nowhere near space centers, who have only vague ideas what astronauts actually do. They're drawn not to the reality years of training, technical procedures, limited missions. They're drawn to what it represents: adventure, discovery, going somewhere no one has gone, doing something extraordinary, being part of something larger than themselves. This isn't childish fantasy. It's human aspiration in pure form. Before we learn about limitations, constraints, reasons things can't be done, we dream freely. We imagine possibilities. We see the moon and think, I could go there. We hear about Mars and think, I want to see it. We look at stars and think, maybe someday. Most children grow out of astronaut dreams. They learn about probabilities, how few people actually reach space, how difficult the path is. They develop other interests, different aspirations. But something lingers, the sense that space represents something important, something worth pursuing, even if you personally won't go there. This cultural significance of space exploration exceeds practical justifications. We don't just tolerate space programs because they produce technologies or gather scientific data. We celebrate them. We follow launches. We pay attention when rovers land on Mars or spacecraft reach distant planets. Why? Because space represents aspiration. It's the concrete embodiment of the idea that humans can do more than survive. We can explore, discover, push boundaries, achieve things that seem impossible. The Apollo program inspired an entire generation, not just to become astronauts or engineers, though many did, but to believe that difficult things are achievable, that dedication and effort can accomplish extraordinary goals, that humanity has potential beyond everyday concerns. Students who watched Apollo missions went into various fields, but they carried that sense of possibility with them, the knowledge that humans can do remarkable things when we try. Artemis offers similar inspiration. A generation has grown up with space exploration being robotic missions and space stations, impressive but not frontier feeling. Artemis brings back human exploration of new territory, missions that feel daring, astronauts going where we haven't been in decades. That shift from routine to frontier rekindles something, the sense that space is still about exploration, still about pushing limits, still about doing things that challenge us. And this matters for reasons beyond individual inspiration. Cultures need aspirational goals. Societies without them stagnate, becoming focused on maintaining what exists rather than building something better. Space exploration provides that goal clear, challenging, undeniably ambitious. We're trying to become a multiplanetary species, to establish permanent presence beyond Earth, to spread throughout the solar system. That's a goal that spans generations, requires sustained effort, unites people around common purpose. Cynics argue this is distraction from terrestrial problems. Why care about Mars when Earth has poverty, disease, conflict? But this is false dichotomy. Solving Earth's problems doesn't require abandoning aspiration. It benefits from it. People who believe in humanity's potential are more likely to work on difficult problems, less likely to accept that challenges are unsolvable, more willing to invest effort in long-term solutions. Space exploration demonstrates that difficult problems can be solved. We've sent robots to every planet. We've landed on comets and asteroids. We've built space stations. We've returned samples from the moon and plan to return samples from Mars. Each achievement proves capability, shows that challenges that seem insurmountable can be overcome with knowledge, creativity, persistence. And that proof generalizes. If we can land on Mars, maybe we can solve climate change. If we can build permanent moon bases, maybe we can build sustainable cities on Earth. If we can develop life support systems for spacecraft, maybe we can develop technologies that reduce environmental impact. The problems aren't identical, but the mindset is difficult doesn't mean impossible. Challenges are opportunities for innovation. Limitations can be overcome. There's also something about space that generates hope. When you look at humanity's problems, conflict, poverty, environmental destruction, they can seem overwhelming, perhaps unsolvable. But then you see images from Mars rovers, or launches carrying crews to the space station, or plans for missions to Europa and Titan, and suddenly the perspective shifts. We're a species that can do extraordinary things. We have capabilities, creativity, determination. Maybe our problems aren't as intractable as they seem. This hope is valuable. Not naive optimism that ignores difficulties, but grounded confidence based on demonstrated capability. We've done impossible things before. We can do them again. Space exploration is proof, ongoing and visible, that human achievement continues, that we're still reaching, still growing, still accomplishing things our ancestors couldn't imagine. The Artemis 2 crew carries this symbolism, whether they want to or not. They're not just testing systems or gathering data. They're embodying human aspiration, representing the drive to explore, demonstrating that we haven't stopped pushing boundaries. When they orbit the moon, millions will watch, participate vicariously, feel connected to something larger than individual concerns. And some of those millions are children, seeing humans do something extraordinary, realizing that space isn't just history or science fiction, but something happening now. Some will dream of becoming astronauts. Most won't achieve that, but they'll carry the aspiration forward, the sense that remarkable things are possible, that humanity's potential exceeds current achievement, that there's always something more to reach for. This is what makes space exploration culturally important beyond practical benefits. It's inspiration made manifest. It's aspiration given concrete form. It's the dream of reaching beyond Earth turned into actual missions, actual spacecraft, actual humans venturing into environments where we don't belong but go anyway, because we can, because we're curious, because we refuse to accept limits. Artemis specifically brings this to a generation that's mostly experienced space through screens and distant news. Seeing humans return to deep space, watching missions that feel adventurous rather than routine, following progress toward moon bases and eventual Mars missions, this makes space feel relevant again, current rather than historical, something their generation is doing rather than something their grandparents did. And relevance matters for maintaining support. Programs that feel distant or abstract are easy to defund when budgets tighten. But programs that inspire, that capture imagination, that make people feel part of something important, these persist despite difficulties because the public wants them to succeed. We go to space because we dream, because humans need aspirational goals, visions of what's possible, proof that we can achieve extraordinary things, because hope requires evidence and space exploration provides that evidence in forms that resonate emotionally, images of other worlds, humans venturing into the unknown, achievements that seemed impossible before we did them. This isn't separate from practical reasons. Dreams motivate the work that achieves practical benefits. Inspiration drives students into science and engineering, creating the workforce that develops technologies and solves problems. Aspiration provides direction, defining goals worth working toward even when immediate benefits aren't clear. But even divorced from practical benefits, dreaming matters. It's part of being human, imagining possibilities, believing in potential, refusing to accept that current state is final state. Space exploration embodies this. It says we're not finished, not settled, not content with Earth alone. It says we're reaching, growing, becoming something more. And when children watch launches or see images from Mars or hear about plans for moon bases, they absorb this message. Maybe they'll become astronauts, engineers, scientists, or maybe they'll become teachers, artists, leaders who carry that sense of possibility into whatever they do. Either way, space exploration has touched them, given them a vision of human potential, shown them that extraordinary achievements are real, not imagined. We go to space because we dream of being more than we are, of achieving more than we have, of reaching beyond current limits toward possibilities that seem distant but become achievable through effort and time. The dream drives the reality. The aspiration motivates the work, and the achievements prove the dream was worth holding. Artemis 2 is 4 astronauts orbiting the moon. It's also millions of people watching, dreaming, imagining themselves out there, feeling part of humanity's reach beyond Earth. Both are real, both matter, and together they create something larger than either alone. A civilization that looks to the stars not just with instruments, but with hope, not just with curiosity, but with determination to go there, to see for ourselves, to make the dream real. The Artemis 2 crew is training right now. In facilities around the world, they're running simulations, practicing procedures, preparing themselves physically and mentally for a journey that only 24 humans have taken before. They'll board Orion, leave Earth, travel farther than anyone has ventured in over 50 years. They'll see the moon up close, watch Earth shrink to a small blue sphere, experience what so few have experienced. And when they return, people will ask them, "Why did you go? What's the point? What did you accomplish?" The easy answers will come first. We tested systems. We gathered data. We proved capabilities needed for future missions. All true, all important, but not the real answer, not the complete truth. Because the real answer is harder to articulate. We went because we're human, because humans explore, because when we see frontiers, we cross them, because staying confined to Earth when we can reach beyond it feels wrong in ways that transcend logic or practical justification. We go to space for survival because keeping all humanity on one planet is gambling with extinction, and the odds eventually favor disaster. We go for curiosity because mysteries exist and we need answers, because the unknown calls to us and we cannot resist. We go for perspective because seeing Earth from outside changes how we see ourselves, reveals our unity beneath apparent divisions, makes planetary problems feel both urgent and solvable. We go to answer questions that can only be answered through exploration. Are we alone? How did life begin? What's our place in the cosmos? We go because it's hard, because difficulty drives innovation, forces us to develop capabilities we'd never develop through comfort. transforms us through the process of achieving impossible goals. We go for resources because Earth is finite and space offers alternatives that reduce pressure while protecting terrestrial environments. And we go because we dream, because humans need aspirational goals, visions of what's possible, proof that we can achieve extraordinary things, because hope requires evidence, and space exploration provides that evidence in forms that resonate across generations. These reasons overlap, reinforce each other, create a web of motivation stronger than any single justification. You can't separate survival from aspiration, or curiosity from perspective, or resources from the difficulty of obtaining them. They're all connected, all part of the larger answer to why we go to space despite the danger and cost and distance. But there's something deeper still, something that underlies all these reasons but resists easy articulation. It has to do with what we are fundamentally, what consciousness means, what it signifies that matter organized itself into forms capable of contemplating the universe. For billions of years, Earth existed without awareness. Continents formed and eroded, oceans filled and evaporated. Life emerged, evolved, died, evolved again, but none of it knew. None of it understood what it was or wondered why it existed. Reality unfolded without witness, without interpretation, without meaning. Then consciousness emerged. Somehow, through processes we still don't fully understand, matter became aware. Neurons firing in patterns that create subjective experience. Brains asking questions about their own existence. Intelligence contemplating the cosmos that created it. This is extraordinary beyond our ability to fully appreciate, because we're always inside it. We can't remember not being conscious, can't truly imagine what existence without awareness would be like, but it would be nothing. Not darkness or silence, those are experiences, just nothing. Reality existing, but no one experiencing it, no one knowing it exists. Consciousness changes this fundamentally. The universe becomes aware of itself through us, experiences itself, understands itself. When humans look at stars and wonder what they are, that's the universe questioning its own nature. When we build telescopes and spacecraft and investigate cosmic origins, that's the universe studying itself, trying to understand how it came to be. This might be rare. We don't know how common consciousness is, whether it emerges easily wherever conditions allow or require such improbable circumstances that we're unique in the observable universe. But whether common or rare, it's precious, because without consciousness, reality might as well not exist. There'd be no one to experience it, understand it, care about it. And this brings us to something profound about space exploration. It's not just practical or scientific or inspirational. It's consciousness extending its reach, awareness expanding into new territories, the universe's capacity for self-understanding growing as we explore regions we've never examined directly. When rovers land on Mars and send back images, that's the first time anyone has seen Mars from ground level. Before that moment, Mars existed rock and sand and atmosphere, billions of years of geology, but no consciousness experienced it. It was there but not witnessed, real but unknown. The rover changes this. Suddenly, Mars becomes known, experienced, understood at least partially. A small piece of the universe's capacity for self-awareness arrives on another world. This will intensify with human exploration. Robots gather data, but humans experience. When astronauts walk on Mars, they won't just collect samples and conduct experiments. They'll feel the gravity, see the landscape directly, experience what it's like to stand on another world. That subjective experience matters in ways data collection doesn't capture. It's consciousness expanding its domain, awareness spreading beyond Earth. And this expansion might be what consciousness does. Perhaps what it's for, if for means anything in evolutionary terms. Life spreads. That's fundamental to what life is. It reproduces, expands, fills available niches. Maybe consciousness spreads too. Maybe intelligence that emerges on a world naturally reaches toward other worlds, driven by curiosity and wonder, and the inability to remain confined when expansion is possible. If so, we're following a pattern, not unique behavior, but something consciousness does when it develops sufficient technology. And if this pattern is common, if intelligence throughout the universe tends toward exploration and expansion, then maybe we'll encounter others eventually. Not because they visited us, but because we both reached outward, following the same drive, consciousness seeking to understand more of the reality that created it. Or maybe we're alone. Maybe consciousness is so rare that we're the only instance in the observable universe, the only time matter organized into patterns capable of understanding. If so, that makes us precious beyond measure. We're the universe's only way of knowing itself, the only consciousness examining reality, the only awareness that exists anywhere. And that would mean we have responsibilities. To preserve ourselves, obviously extinction of the only consciousness in the universe would be cosmically tragic. But also to spread, expand, ensure that consciousness persists and grows. Because if we're the universe's only way of understanding itself, then expanding our understanding, reaching new worlds, investigating new phenomena, that's literally increasing reality's self-awareness. Either way, common or rare, one of many or unique consciousness exploring space matters in ways that transcend immediate practical benefits. Its awareness expanding its domain, understanding deepening, the universe's capacity for self-knowledge growing. The Artemis 2 crew probably won't think in these terms while orbiting the moon. They'll be focused on procedures, systems checks, the immediate tasks of their mission. But in quiet moments, looking at Earth or at the lunar surface, they might feel something, a sense of significance, of participating in something larger than technical accomplishment. The first humans beyond Earth orbit in 50 years, proving we can return to deep space, paving the way for others who'll go farther still. And that lineage matters. Apollo astronauts walked on the moon. Artemis astronauts will return there, stay longer, build infrastructure. Eventually, others will live there, then journey to Mars, then establish presence throughout the solar system. Each step extends consciousness's reach, expands awareness's domain, increases the universe's self-understanding. This is destiny, not in the sense of predetermined fate, but in the sense of natural development. Consciousness that emerges on a world and develops technology will eventually wonder about other worlds, then visit them, then spread beyond its origin. Not because it must, but because it can, and because the drive to explore and understand is fundamental to what consciousness is. We go to space because we're conscious beings in a vast universe, and remaining confined to one small world when we can reach beyond it is intolerable. Not immediately. Most people live their entire lives on Earth contentedly. But as a species, as a civilization, as consciousness expressing itself through human form, We cannot stay still. We push boundaries, we explore, we reach. The 7 reasons we've explored survival, curiosity, perspective, answering questions, difficulty, resources, dreams are all expressions of this deeper drive. Their specific motivations arising from the general fact of being conscious intelligence on a world surrounded by cosmos. We go to space because we're human, yes, but more fundamentally, we go because we're aware, and awareness seeks to expand its understanding of reality. This won't end with the moon or Mars. If we survive, if we persist, we'll eventually reach asteroids, the outer planets, their moons. We'll build rotating habitats in space, establish industries operating in vacuum, develop civilizations that span the solar system, and eventually, if we last long enough, develop technologies that allow interstellar travel, carrying consciousness to other star systems, spreading awareness through the galaxy. These timescales exceed human lifetimes, exceed nations, or even civilizations as we understand them. But they're achievable if we persist, if we don't destroy ourselves, if we maintain the drive to explore and the capability to act on that drive. The path from Artemis to galactic civilization might take millennia, but it starts now with missions like Artemis 2, proving we can leave Earth, survive in space, explore new territories. And even if we never achieve galactic scale, even if we remain confined to the solar system, the expansion matters. Each world we reach, each place consciousness extends its domain, increases reality's self-awareness. The universe understands itself better when humans walk on Mars than when Mars remains unexplored. Reality becomes more fully known when rovers examine Titan than when Titan exists unobserved. This is what we do. This is what consciousness does. It explores, investigates, seeks to understand the reality that created it. Space exploration is that process made concrete consciousness, extending its reach, awareness expanding its domain, intelligence investigating the cosmos that gave rise to intelligence. The practical benefits are real. The technologies developed, the resources accessed, the survival advantage of becoming multiplanetary, all valuable. But they're secondary to something more fundamental. We go to space because we're conscious beings in a universe that mostly isn't conscious, and expanding awareness's domain feels right in ways that transcend practical calculation. When the Artemis 2 crew returns and people ask why they went, the answer will be multi-layered. For science, for technology, for inspiration, for all the reasons we've explored. But underneath all of that is simpler truth, because we're human, because humans go to frontiers, because consciousness explores, because when you can reach beyond your current domain and you don't, something essential is lost, not practically, but spiritually, in the sense that you're denying a fundamental aspect of what consciousness is. We are the universe aware of itself. That's not metaphor or poetry. It's literal. The atoms in your body were forged in stars. The consciousness in your brain is matter organized into patterns capable of understanding. When you look at the night sky and wonder what's out there, that's the universe questioning itself, reality investigating its own nature. And when we build spacecraft and send them to other worlds, that's consciousness expanding its reach, awareness extending its domain, the universe's capacity for self-understanding growing. Each world we explore becomes known, experienced, understood. Each discovery adds to reality's self-awareness. Each mission increases the universe's ability to comprehend itself. This is why we go to space. not for any single reason, but for all of them simultaneously, each important, each valid, each part of the larger truth that consciousness seeks to understand reality, and understanding requires exploration. We go because we must, because we're curious for perspective and answers and resources and dreams and the challenge itself. But most fundamentally, we go because we're conscious, and consciousness expands. It reaches, it explores, it seeks to understand more of the universe that created it. Space is where that expansion leads when consciousness develops on a world. Not immediately, not without effort, but inevitably if we survive long enough. The Artemis 2 crew will orbit the moon. They'll test systems, gather data, prove capabilities, and they'll participate in something larger consciousness extending beyond Earth. Humanity taking steps toward becoming a spacefaring civilization, intelligence expanding its domain in ways that will continue long after their specific mission ends. This is our nature. This is what we do. And the fact that we're doing it again after 50 years focused elsewhere suggests something important about human persistence. We pause sometimes. We get distracted by immediate concerns. But eventually we return to exploration, to pushing boundaries, to reaching beyond current limits. Because we're explorers. We're curious. We're consciousness that cannot remain confined when expansion is possible. We're humans looking at the moon, at Mars, at distant stars, and feeling pulled toward them, not by logic or calculation, but by something deeper, the fundamental drive to understand more. Explore farther, expand awareness's domain. Tonight, look up. Those stars are real places. Other worlds orbit them. Distance separates us, but distance can be crossed. Not easily, not quickly, but crossable. And knowing that the universe isn't just something to look at, but something we can explore, something consciousness can expand into, something we can eventually spread awareness through, that changes everything. We're at the beginning. Not the beginning of space exploration that started decades ago, but the beginning of something larger. Humanity becoming a spacefaring species, consciousness extending beyond its origin world, intelligence spreading through the solar system, and eventually beyond. The Artemis 2 crew is 4 people on one mission, but they're also representatives of something larger human aspiration, conscious exploration, intelligence reaching beyond Earth, because that's what consciousness does when it can. They go for practical reasons and philosophical ones, for survival and dreams, for resources and inspiration, and all the reasons that matter to conscious beings contemplating the cosmos. And when they return, when they've proven we can go back to deep space, when they've tested the systems that will carry others farther, they'll have done something important. Not just accomplished mission objectives, but proved that humans still explore, still reach, still push boundaries. That space is still frontier. That consciousness continues expanding. This is why we go to space. All the reasons simultaneously, overlapping, reinforcing. Because we must. Because we're curious. For perspective. For answers. Because it's hard. For resources. Because we dream. And beneath all of that, because we're conscious, and consciousness explores. Because we're aware, and awareness expands. Because we're human, and humans go to frontiers. The moon is waiting. Mars beyond it. The outer planets, the asteroids, the distant stars. They've been waiting for billions of years, existing but unknown, real but unexperienced. And now, finally, consciousness is reaching toward them. Slowly, carefully, but inevitably. We go to space because we're conscious beings in a vast universe, and remaining confined to one world is intolerable. Not because someone demands we leave, but because the drive to explore, understand, expand is fundamental to what we are. So we go, today with Artemis, tomorrow with Mars missions, eventually throughout the solar system and beyond. Because consciousness expands, because intelligence explores, because humans reach toward horizons, because we're aware and awareness seeks to know more of the reality that created it, because we're alive and life spreads, because we're human and humans go to space. That's why